this one, we want to kind of just sketch out what we're given. So this is based on the probability of the absolute value of z being greater than z0. So given that, we would just want to see, well, what does this look like on our graph? So we have a z0, and we have the probability that z is greater than that is 0.9, but we could also have z being less than negative z0. So this is again where we break it, where we have an absolute value and you would break it into two pieces.
Oh, okay.
Really exactly the same as part A, because you could think of this as the probability of the absolute value of z minus 0 greater than z0, because it's a standard normal distribution, so it's centered at 0. So it's really exactly the same idea like we did in 2A.
Okay.
Except instead of being given that value of 2, now we have an unknown, z0, and we're given the probability. That's how you know if it's an inverse problem, is if you have a specific probability that you're looking for. Like problem 4 is another example of an inverse normal distribution, where they tell you we want the 80th percentile. So what value gives us the 80th percentile? And you have to solve for that. That's an inverse problem. If you're given the probability, it's inverse. If you're asked to find the probability, it's just a regular, probability distribution type problem. So what problem do people want to do next? I think 8 is kind of just for fun. I mean, the only problem with 8 sometimes that, I see a question here. 7, somebody wants 7. Okay, we can do 7. But I just wanted to mention 8 because somebody had asked about 8. For 8, you have a situation where, you're looking at the different bets in a casino. And so you have all these different possible, different outcomes for 1,000 bets. And so you're looking at the average winnings per bet. So in each case, you bet $1. So you might lose, if you don't win anything, you lose, your winnings is -1. If you get $1 back, your winnings are 0. If you get $2 back, your winnings are 1. If you get $5 back, your winnings are 4. And so it asks you to compute average winnings per $1 bet. Well, to calculate the average, we always need a total divided by n. And so what's our total? Our total is the money that we get back, our total payout minus what we put in. So we kind of have to calculate that here. Okay, for 600 bets, we didn't get anything. So we lost $1 on those bets because we paid 600 and we got back 0. So we're just going to calculate our total payout, how much we get back versus how much we put in. And so we get a total back of 900, but we put in $1,000. So our net winnings is -100. Because we paid $900, but we paid $1,000, we only got back 900. So our X bar is going to be our total -100 over 1,000. And then you use that value to calculate your standard deviation. So you can calculate, so it shows you the standard deviation calculation, and then you can use all that to calculate the confidence interval. We always have to calculate the standard error, which is S over the square root of n, and everything kind of works out.
Sorry, how do you get the net winnings per bet in B? Like the -1, 0, 1, and 4. Can you just explain that again, please?
Oh, for the net winnings. Okay. So for the net winnings, let's say your payout is 0. but you put in $1. So for that specific bet of payout being 0, but in every case you put in $1. So for those 600 bets, your value is -1. So if you want to calculate the standard deviation and estimate, okay, what's the mean minus the specific value? We calculated the mean above, we get -0.1. On average, we lose 10 cents per bet. But for these specific bets where the payout is 0, we lose $1. So for those, it's -1. So we're taking -0.1 minus -1 squared, and then we're squaring all of those. And then we're going to multiply that by 600 that we do below. And so for these bets where we put in $1 and we got back $1, we didn't win anything. So we are at 0. So for there, we do -0.1 minus 0 squared. Now, for the ones where we got $2 back, well, we put in $1, we got $2 back. Our net winnings for those bets is $1. So we do -0.1 minus 1 squared. And then for those bets where we put in $1 and we got back $5, our net winnings there is 4. So we're using the same formula in each case. We're looking at each different value subtracted by the mean squared. We want those deviations. So we're centered at the mean, and we want to calculate all of our squared deviations for all of our different outcomes. So here our squared deviation is -0.1 minus 4. And then we square those, and then we add up how many different outcomes. And so we're basically just using this S squared formula. And we get, our 2.292, and we take the square root and we get 1.514. Does that answer your question?
Yes, thank you. Yes.
Okay.
Are we going to be able to have a piece of paper during the test?
A piece of paper? Yes. Yeah, you can have all the blank. Yeah, you're going to need blank paper for sure. So, if you have like a printer at home, like I just got this from my printer. So you could just have that. Does everybody have paper? You could take out a notebook paper. I would pull out the sheet so, it doesn't look like, maybe pull out 5 or 6 sheets for you to write on. You're going to want to, have that plus your calculator. You would want to kind of draw a sketch out of the for the normal distribution problem. Like we said, the sketching really helps students, things like that. Can we have the formula sheet? Yes, you have a formula sheet. I posted that. Does everyone have the formula sheet? You do have it. Okay. Good.
Also, to be clear, you said we can have the formula sheet on our iPads or tablets.
Yeah.
Can we also use the calculator on our tablet?
I'm sorry?
Can we also use the calculator on our tablet, or do we need an actual calculator?
I would try to maybe use I would use your tablet as little as possible because it could set off an alert. I mean, we don't have a lot of practice with this system because it's new. But I would just if you need to use the tablet for different things, you can kind of have it there the only thing you're really going to need is the normal table. That one is you're going to want to have. And if you could, the best would be to copy the formula sheet on a page so that you don't have electronic devices are going to set off alerts. So the less you can use electronic devices during your test, the better. But if you need it for the normal table, you can have just that, and it's probably will not it's not going to cause a problem. If you're, sending text text on your phone or doing things like that, it's probably going to set off an alert. But that's kind of like a last resort to use a tablet to download the